Okay. At this point, you have watched the video that's shown how to calculate or determine conjugate acid-base pairs. And you know that a conjugate acid is always found by adding H plus to a chemical. Conjugate base is always found by subtracting H plus from a chemical. Um, you've seen that the pH is equal to the negative log of the hydrogen ion concentration, and that hydrogen ion concentration is going to be represented by molarity. And then you've seen that the pOH of a base is represented or calculated as the log of the molarity of the hydroxide concentration. So both of those are based on molarities. So I want to show you how to work backwards from those. And that's really, I don't have a video on that. Didn't realize I didn't. So we're going to go through it right here. Let me open this window here. Okay. So what you've learned is that the pH is equal to the negative log of the hydrogen ion concentration. pH represents power of hydrogen, and it is a logarithmic scale, which I've already mentioned. The pOH is equal to negative log of the hydroxide concentration. Now, we don't generally measure pOH directly, so you've seen that the pH plus the pOH is going to be equal to 14 if we're doing it room temperature, and everything we're going to consider at this point will be room temperature. It does drop if it's heated. So it'll go lower, and so our neutral will shift off of 7.0. The reason neutral 7.0 is the 14. It's halfway there. And you should know at this point that there's no limits between 1 and 14 or 0 and 14, like the biologists typically will tell you. It can definitely go negative. It can go above 14. All right. So what we want to understand now is how to go backwards. If we have the pH, how do I determine the hydrogen ion concentration? How do I determine the hydroxide concentration? So if we go backwards, we're going to find out that the hydrogen ion concentration is going to be equal to 10 to the negative pH. Okay, and you've got a 10x button on the calculator that's made for it. Just like you have a log button, you have a 10x button. And then the hydroxide concentration is going to be equal to 10 to the negative pOH. Okay, so hydrogen ion concentration, 10 to the negative pH, hydroxide, 10 to the negative pOH. There's no limit on the determination of this strong acid, strong base. If we have the pH, we can get the H plus concentration regardless of what the acid is. Whereas if we have the concentration of an acid or a base, it needs to be strong for us to determine the pH or pOH. So going backwards is always 100%. Okay, so let's say we have a pH equal to 4.0. Okay, we want to calculate both the hydrogen ion concentration and the hydroxide concentration. Okay, well, my pOH is going to be equal to 10.00 because they must add up to equal 14. So then my hydrogen ion concentration is going to be equal to 10 to the negative 4.00, since that's the pH. My hydroxide concentration is going to be equal to 10 to the negative 10.00 because that's the pOH. Okay, so I'm going to switch here and we're going to go to the calculator just so I can show you it being done on the calculator. So let's stop presenting for a second and switch this to the calculator. Okay. All right, so this is obviously the PC calculator, and you can see over here on the left, there's a log button and a 10 to the X button. There's a log here, a 10 to the X here, okay? So what we're going to do is clear all this, completely clear it. There we go. And we want to do the calculation for 4.0. So I'm going to say my pH is 4.00. I'll make it negative. and then I'm going to raise it 10 to the x. That means that the hydrogen ion concentration is 0.001. Okay, 0.001. Then we could go do the same thing with the 10, and I'm going to have 10, negative 10, and I'm going to go 10 to the x, and I'm going to get 0.001. Now, what I'm going to do there is I'm going to switch that to scientific notation. So you can see that 1 times 10 to the minus 10. So it's 1 times 10 to the minus 4 and 1 times 10 to the minus 10. So let's stop sharing that. Let's go back to OneNote. Nice. Not showing me OneNote. Bring it up. But again, still not showing me OneNote. All right. There we go. Anyway, all right. So now we know that the hydrogen ion concentration equals 1.0 times 10 to the minus 4, or the answer that came up on there is 0.0010. And then this one is going to be equal to 1.0 times 10 to the minus 10. Okay, but I'm not going to write that out with the zeros. All right, well, let's do something that's not so obvious. pH 4 and 10. Let's do a pH of 2.8, 2.82, typical vinegar solution. And so if the pH is 2.82, then the pOH is going to be 11.28. So now I can go through and say, all right, my hydrogen ion concentration is going to be equal to 10 to the negative 2.82. My hydroxide concentration is going to be equal to 10 to the negative 11.28. All right, let's switch real quick. Stop presenting that. I'm going to switch to my calculator. Hopefully I can still see it. I can. So I had 2.82 and 2.82 and 11.18 should have been that. I put 2.8 there, but it is 11.18 for 2.82. All right, so we want to go in. We're going to put in 2.82, make it negative, and then hit the 10x. So 1.51 times 10 to the minus 3. Or really 1.5 times 10 to the minus 3 with the correct number of significant figures. So 1.5 times 10 to the minus 3, and then the other one's 11.18. So we're going to have 11.18 plus or minus, and then hit the 10x. 6.6 times 10 to the minus 12. So 1.5 times 10 to the minus 3, 6.6 times 10 to the minus 12. So let's go out of that. Go back to OneNote. It'll show it to me. It will not. So let me bring up OneNote. And we will. There we go. Now we got it. All right. So this actually was 11.18. Hopefully some of you caught that mistake. And so this would be 11.18. Add that. So now my hydrogen ion concentration was 1.5 times 10 to the minus 3. And my hydroxide concentration is 6.6 times 10 to the minus 12. Okay, so that's going to be how we're going to handle going backwards with pH and pOH to the respective H plus and hydroxide. The only thing that isn't mentioned at the bottom, it has to name the 6 strong acids, because we can only do acid calculations with those 6 strong acids. And so you can definitely look that up and do that. All right. So we're going to stop this recording.